Alright guys, this is the final exam review for the summer session 2023-24. These are the topics that we have studied after the midterm exam. Probability lecture 1, probability lecture 2, probability lecture 3, probability lecture 4. There are 4 lectures on probability. Not simple lecture 1, 2, 3, 4, 5. They were covered in midterm. So I will, as in the email, I told you that these are the questions, 2 questions, and there will be one question from binomial distribution, one question from Poisson distribution, and one question from normal distribution. So these discrete continuous random variable were there in the quiz, so I decided not to give any question from there. And also this one, probability lecture 4, this was given with discrete and continuous random variable in assignment 3. So these 3 lectures are given in assignment 2, and these are given in assignment 4. So essentially assignment 2 and assignment 4 are there in your exam. So let's do one by one. So I will, as I said, one question will be in probability. There are 2 questions. So one question from simple probability questions, right? And one question will be from conditional probability, which is lecture 3, right? Conditional probability. So these are probability lecture 1 and 2, and this is from probability lecture 3. Okay, so these are not just lecture 1 and 2, these are probability lecture, simple probability question from probability lecture 1 and 2. So if you look at assignment number 2, there are I can open assignment 2 for you. So in assignment number 2, you can see that at the beginning there are some questions like these are simple questions. I think I did couple of questions in the exam as in the class as well. So I think up to here, these are simple probability questions. Okay. So first 1, 2, 3, 4, 5. First 5 questions are assignment 2, and last 4 questions are from conditional probability. So I can write here or I can say first page of assignment 2, and this is the second page of assignment 2. Okay, first page of assignment 2, second page of assignment 2. One problem from there. So, and these binomial, normal, Poisson distribution, they are written on your assignment 4, the questions from binomial. So binomial, Poisson, and normal. So let's see if I do some problems from assignment 2. So let's say assignment 2 here. So if I go to the simple questions, for example here, rolling of a die, flipping of a coin, these type of questions can be there. You see here, fair coin is rolled. So where is the straw? You see this one, a pair of fair dice is tossed. Find the probability of getting a total of 8, at most total, so whatever. So as an example, we can say that two coins are tossed, right? Or one coin, three coins are tossed, right, etc. Or two dice are rolled, right? These type of questions, etc. So I can ask you, okay, two coins are tossed, what is the uh, sample space? Write the sample space for that. So you know that sample space is S, and if we toss two coins, there can be head on both, head on first, tail on the second, tail on first, head on the second, or both tails, right? You can do it like this as well, that head, tail for one toss, and now head and tail both can have head, tail, head, tail, right? So see now, head, 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 tail, head, tail. So if you combine them, head, head, tail, head, tail, you will exactly get these four outcomes, right? So then right after writing these four outcomes, you can find the probabilities. For example, what are the probabilities of all these things? So you can write probability of two heads, let's say. So there is only one case when you get two heads and total are four. So 1 by 4 will be the probability of two heads. One head, one tail. Or you can say that what is the probability of, instead of this one, you can say that what is the probability of two heads, right? What is the probability of one head and one tail, right? So it means there are two cases when you have one head, one tail. So 2 by 4, which is 1 by 2. Similarly, probability of two tails. There is only one category when you have two tails, so it's again 1 by 4. So you can do an experiment, define a sample space, write all the sample points of it, and then find the probability of all sample points. Similarly, if I roll two dice, if two dice are rolled or thrown, right, then for the sum on two dice, so I can write sample space for the sum on two dice is, what will be that? We can write sample space as, we can write 1 2 3 4 5 6. This is your first die. 1 2 3 4 5 6, that's your second die. So they are not the part of your sample space. The sample space will be inside here. So 1 plus 1 2, 1 plus 2 3 4 5 6 7, 2 plus 1 3 4 5 6 7 8, 3 plus 1 4 5 6 7 8 9, 4 5 6 7 8 9 10, 6 7 8 9 10 11, 7 8 9 10 11 and 12, right? So from 2 to 12, so your sample space is basically set of all points from 2 3 4 up to 12. So this is your sample space basically. And now if you want to find the probabilities of all, what is the probability that the sum is 2? It is 1 by 36, because there is only 1 2, right? What is the probability of 3? So there are two 3's here, you see, two 3's. So it means 2 by 36, which is 1 by 18, right? Similarly, probability of 4 5 6 7. For example, if you want to write what is the probability of 7, so 7 are 1 2 3 4 5 6. So it is 6 by 36, which is 1 over 6, and so on. So you can keep on. So for example, what is the probability of 12? So on. You can write all the probabilities. Probability of 12 will be again 1 by 36. So you can write all the probabilities here, not just 2 3 4. You can write all the probabilities. If they don't ask you all probabilities, then no need to write. For example, in this assignment, they said what is the probability of getting a total of 8. So see, what is the probability of getting a total of 8? There are, how many 8s are there? 1, 2, 3, 4, 5. So probability of getting a total of 8 is 5 by 36, because there are 5 cases when you get a sum of 8 out of 36. So 5 by 36 will be the probability, and so on. So these are simple questions. Here you see a poker hand consisting of 5 cards. Find the probability of holding 3 aces, 4 hearts, 1 club. So see, when you are selecting, another example, I can say, selecting a poker hand of 5 cards. A hand of 5 cards. Okay. So how many ways you can select 5 cards? So in how many ways you can do this, or you can see total number of ways. So total number of ways. Total number of ways you can do this thing means selecting 5 cards out of 52. You see, this is a selection. Total cards are 52, you are selecting 5. So selecting 5 out of 52, C5. So you can use calculator and write the answer. And then now if they ask what is the probability that you get 3 aces. Now you know that there are, how many aces there are? There are 4 aces. Right? So I am not interested in what are other cards. Other cards are all same for me. So other 48 cards are same. So it means you are getting 3 aces out of 4 aces. You see, 3 aces out of 4 aces, and remaining 2 cards will come from other 48 cards, because total is 5. And these are the number of ways you can choose 3 aces out of 52 cards. So divided by the total number of ways, so which is 52C5. So you can write the answer. Second question was, what is 4 hearts and 1 club? You know that there are 13 hearts and 13 clubs. 4 hearts and 1 club. We know that there are 13 hearts. So you are selecting 4 out of it. And there are 13 clubs as well, and you are selecting only 1. Now there is nothing left, because 5 complete. 4 hearts and 1 club. So there is nothing left. So it means divided by total number of ways. So that's how you. So when you are selecting more than 1 items, you cannot just divide 3 by 4 by 52. If I ask you what is the probability of 1 ace if I am selecting 1 card at a random, then it is 4 by 52, because there are only 4 aces, total are 52 cards. 4 by 52 is when I select 1 card only. If you are selecting more than 1 cards, then you use combinations. Okay, 2 cards, 3 cards, 5 cards, 10 cards, whatever it will be given to you. So these are probability questions. Now, for example, here a probability that an American industry will locate in Shanghai, China is 0.7. So I can say that the probability that let's say S for Shanghai, right, and B for Beijing. So I can say B for Beijing. So let's say probability of S is 0.7. Probability of Beijing is 0.4. And the probability that it will locate in either Shanghai or Beijing. It means probability of S or B. This union is used for OR. Okay, union is used for OR. It is the same thing. That is 0.8. Right, 0.8. What is the probability that the industry will locate in both the cities? So see, both means and. S and B. And is intersection. Okay. So and intersection is the same thing. We know that the probability is we can add Shanghai and Beijing and subtracting OR. This is the formula from the probability. So we know that probability of S is 0.7, B is 0.4, and S union B is 0.8. So 7 plus 4, 11 minus 8 is 0.3. This is the probability that it will locate in both the cities. Both means S and B, Shanghai and China. And in neither of the cities. Neither of the cities means probability of neither S means S complement and neither Beijing B complement. Complement means not S, not B. Okay, in neither of the cities, not in Shanghai, not in Beijing. So you can use this as one complement. You can write S union B to the power complement. When you bring complement outside, this intersection becomes union. Union becomes intersection. Then when there is a C outside, you can subtract from 1 and remove the C. So S union B will come here, S union B, and C is removed. Now S union B is 0.8. You know that. S union B is 0.8. So you subtract this from 1, the answer is 0.2. So 0.2 is the probability that it will not locate in any of the cities. Alright. So you can note it down from here. You can pause the screen and note it down. And then there is a conditional probability, the second page of assignment, right? Second page of assignment 2, right? So this is about conditional probability. So I can, what is conditional probability? It is probability of A given B, right? So means you are not looking for just the probability of A. You are looking for a probability of A when there is a given condition. So B is a given event. B is a given event. Given event means an event that has already occurred. B has already occurred. So it is a condition which is given to you. And now tell me what is the probability of A. So the formula is that probability of A and probability of B divided by probability of B. So whatever is the given event, it comes down, you see. The given event comes down. Okay. So and means intersection. And intersection are the same. So whatever you want to write, it's fine. So you need this thing. So let's see. We can attempt a question. A class of advanced physics is composed of 10 juniors. So let's say I use J for juniors, S for seniors, and G for graduate students. The final grades show that 3 of juniors, 10 of seniors, and 5 of graduate students received an A grade. Okay. If a student is chosen at random from this class and is found to have earned an A. So see, this is the given condition. So let's say A is for grade A, received a grade of A. So I can say that that a student received A grade. A student got an A grade, right? Now he said, what is the probability that she is a senior? So they are asking you, what is the probability that the student chosen is a senior, given that he has already scored an A grade? You see, if a student is chosen and is found to have an A grade. So let's say I chose a student and I told you that he has received a grade of A. Now you tell me what is the probability that he is a senior, right? So I can say that probability of a senior and received an A grade divided by probability of A grade. Now you see, total are, how many total? 10 plus 30 plus 10, 50. So total students are 50. And how many A's are there? Total A's, 3 plus 10 plus 5, 18, right? 10 plus 5, 15 plus 3, 18 are A grades. So there are 18 A's, A grades, right? A's are 18. Now probability of A will be, probability of getting an A will be total A's divided by total students, 18 by 50. But S and A means what is the probability that he is a senior and he received a grade of A. So there are 10 seniors, you see, 10 of the seniors received A grade. So it means it is 10 by 50, right? There are 10 seniors who received an A grade. So it is 10 by 50. So I can divide 10 by 50 divided by 18 by 50. So if you cancel 50-50, it is 10 by 18, which is 5 by 9. So that's the answer. So this is where we can use the conditional probability. So remember that conditional probability is something when a condition is given to you. Alright. So if condition is not given, it is not a conditional probability. For example, here a random sample of 200 adults, or maybe, right, a married couple living in some town, the probability that the husband will vote on a referendum, on some election. This is referendum is an election kind of thing. So let's say there is a voting going on to elect your people. So he said husband will vote, let's say H is for the husband, is 0.21, and the probability that the wife will vote is 0.28. So probability of wife is 0.28. These are given. The probability that both husband and wife will vote, so probability that both husband and wife will vote is 0.15. Now what is he asking? He is asking that what is the probability that at least one member of the married couple will vote. So at least one member means probability that a husband or wife, right? Or husband or wife. So you know that when it is husband or means union, husband or wife. So husband or wife. Now again we can use the same probability, that husband plus wife and minus the intersection, husband and wife. Okay, so union can be written as the individual probability husband plus wife, and we subtract the intersection. So husband was 0.21, wife was 0.28, and minus they both were 0.15. So that will be your answer. 21 plus 28 is 49, minus 15 is I think 34, right? So 0.34. That is the probability that at least one member from the married couple will vote. A wife will vote, and now you see the B part. A wife will vote given that her husband will vote. A wife will vote given that her husband will vote. This is conditional probability. The first one was not conditional. Now you see probability that a wife and husband divided by only the husband, because given probability comes down. Given. At the top we have both. So what is husband and wife? Husband and wife is 0.15. That is given. 0.15. And divided by only husband, which is 0.21. So you divide these two, that is 15 by 21. 3 5s are 15, 3 7. So 5 by 7 is the probability, right? And similarly you can do the C part as well. A husband will vote given that the wife. So this is the conditional probability. Okay, so this constitutes your 2 questions. So you can again pause the video and note down this answer if you want. So that concludes 2 questions. Okay.